This lecture is about rates of change. More specifically, we're going to talk about average rate of change. So I just have an example here. The population of Kentucky was 3,961,000 in 1999 and 4,314,000 in 2009. And the average rate of change in this particular problem is the change in population over the change in years. So in that particular case, right, I need to pick one and go, say, in the same direction. So if I change in population, I'll start with the bigger, the 4,314,000, and then I will subtract the 3,961 because that was the change, the 3,961,000. That's the difference in the population in 2009 compared to 1999, and over the change in years, that was the 4 million went with 2009, and this 3 million went with 1999. Okay, so when I simplify this, I get 353,000 over 10. Okay, and that is in people per year, or population per year. Okay, so if we divide that out, then that means it's going to change by 35,300 people per year. Okay, and that, oops, sorry, I'm very bad at that. So that's like the average change. It's not changing that way every year, but on average we can say it changes by about that. So then if we wanted to predict what it was in another 10 years, we would add, hopefully if it continues in the same direction, then we would add this per year of, it's a good way to estimate your next year's population. All right. Now you might notice that if I had called this an ordered pair, if I had written it as 2009 as an ordered pair, oops, sorry, let's write it 2009, comma 4,314,000, and the other ordered pair 1999 and then 3,961,000, then these are just ordered pairs, and this is just the slope calculation. So really our average rate of change can sometimes be referred to as the slope, right? So it's exactly the same calculation. Okay, so our average rate of change is, so here's some different ways to represent it, is the change in output over the change in input. So usually our change in output is y, right? And our change in input is x. And so we sometimes call it delta y over delta x. And this triangle, if you've ever taken a science course or something else, maybe you know, this is what we call the delta symbol. And it just means change. We like math symbols that make it easy so we don't have to write out the change in the output and the change in the input. We just say delta y over delta x, and that means the change in y over the change in x. All right, so then here's our slope formula. This is the standard one. Hopefully you've seen it before. The y2 minus y1 over x2 minus x1. The change in y over the change in x. So if I have 2 points, it's the difference in the y coordinates over the difference in the x coordinates. And then another way to represent it is the f of x notation. And we can write it like this. It's exactly the same thing because a lot of times we say y equals f of x, right? So that means also that y1 equals f of x1 and y2 equals f of x2. So it's just another way of writing y. Y is f of x. We plug in an x value in our function and we get out an f of x, which is our y coordinate. Okay, so just another way of doing it, we can compute the average rate of change from a graph, And in this particular case, we find the average rate of change on the interval from, this is interval notation, that means x equals -1 to x equals 2. So I conveniently have these points labeled on my graph, and this here is the point -1, -2. If I didn't label these, sorry, but that is approximately -2. So this point here where it hits the graph is -1, and then the y-coordinate is -2, and then at x equals 2 we come over here and we see that the point 2, 0. So if I want to calculate my change in y over change in x, I'm just going to write m, or average rate of change for short, right, is, I just can pick any y value, so I'm just going to start with the right one, so 0 minus -2. And then since I chose the 0 to start with my y's, then I have to chart the 2 goes with the 0, and that goes first here. So I get 2 minus -1. So the minus 2 becomes +2, and 2 minus -1 becomes +3. So my average rate of change between the 2 points is 2/3. Okay, and this one doesn't have any units on it, so we'll just say units. Okay, but that is our average rate of change. So what if we have a table? Okay, so a table is just slightly easier than a graph. So if we wanted to calculate the average rate of change of annual sales between 1998 and 2004, we would calculate that as the change in sales, right, over the change in years. All right. So the change in, or the sales for 2004 are 370. So I'm just going to write it, I'll just write it like this, right? I use the 370, so I use 2004 first, and then to 1998 is, so that would be 300, and this would be 1998. So I have a fairly easy calculation here. I get 70 over 6. And I can simplify that a little bit down a little bit further. I could change this to a decimal. I'm just going to leave it in this case as 70 over 6, and that is sales in millions per year. Okay. All right, so let's just do another couple of examples. What if we wanted to calculate the average rate of change for f of x squared plus 1 between -1 and 3? So this time I'm going to have to figure out my own y values. So this is between x is -1 and x equals 3. That's our interval notation. So f of -1, in our case, we plug in -1 here, and we'll get -1 squared, which is, I don't know why that happened, why it got blurry, but f of -1 is -1 squared plus 1, which is just 1 plus 1, which is 2. So we have the point -1, 2 as our first point, and then we also need, for x is 3, so f of 3 would be 3 squared plus 1. 3 squared is 9, plus 1 more is 10, so I have the point 3, 10. So my average rate of change is, okay, so I'm going to write 10 minus 2. It doesn't matter which direction you choose them. I just like things to be positive. So 10 minus 2 over, then I started with the 10, so 3 minus -1. So in this case, that would be 8 over 4, which is, in this case, 2. All right, so one more that's a little bit more complicated. This is going to be a little bit more algebraically complicated here. So this time we want to find the average rate of change for the same function, x squared plus 1, between x and x plus h. So this time, instead of getting a specific number, we're going to get an algebraic expression, but it's the same thing. Okay, so we know that these are our x's, right? But we need to figure out what the y value is. So f of x actually is just x squared plus 1. So I'm going to think of this as an ordered pair, x squared plus 1. And then when I plug in x plus h, I'm going to have to do a little bit of algebra here. So x plus h goes with, all right, so if I'd asked for f of 2, then what I do is I plug in 2 for x. This time I want f of x plus h, so what I do is I plug in x plus h everywhere there's an x. So I get x plus h quantity squared plus 1. Now I'm going to simplify this for myself. That'll help in the next step. So I'm going to expand this, and I get x squared plus 2xh, remembering that there's a middle term here, so it's really like x plus h times x plus h. Alright, so I get the x squared here, and then I get an xh here and an xh here, so that gives me 2 of them, and then plus h squared, and then of course with the plus 1. So then I have x plus h, and then this is as simplified as I can get it, is x squared plus 2xh plus h squared plus 1. So these are my 2 ordered pairs. So now I want to find my change in y over my change in x. So I'm going to go with this one first, okay, because that's the bigger one. So my change in y would be x squared plus 2xh plus h squared plus 1, and then I'm going to have it minus this one, right? So it's this minus this. I'm going to use parentheses, x squared plus 1. And then my change in x's, I started with this one, so I have x plus h goes first, and then minus x. Okay, so let's expand this a little bit. When I multiply through the minus sign, I get x squared plus 2xh, so now this is over delta x, 2xh plus h squared minus 1, or I'm sorry, that's a plus there. Now I get minus x squared, and now I get minus 1 here, because this goes to both. And then I have x plus h minus x, which is just h, because the x's cancel each other out. Now the good news is that I have some cancellation here. This x squared and this x squared cancel each other out, and this one cancel each other out. So now I'm left with my change in y over my change in x is 2xh plus h squared over h. Now we can leave it like this, or we can notice that there's h's up here and an h down here. So if I factor out the h at the top, I get 2x plus h over h, and now these can cancel. I can't just cancel it from one. It has to come out of both, so I factor it out. So in this case, my average rate of change is 2x plus h. Oops, sorry, you couldn't see that. Okay, so here I factored out the h, I canceled them, and then I'm left with 2x plus h. All right.